Hello and welcome to Module 7 of CIS64F. In this module, 070, we will touch on Part 2 of the Business Analysis Lifecycle. We'll make some comments about rudimentary exploratory data analysis, forming preliminary business hypotheses, and we'll have the midterm and a few other things. As we begin, let's revisit our purpose. Our purpose in the context of this course and as information systems professionals is to ensure that data delivers value to the enterprise. So everything we do is intended to deliver value to the enterprise using data analysis, reasoning, conclusions, etc. In this thrilling episode of CIS64F, we will get into the Business Analysis Lifecycle Part 2 of 2. We'll have some comments about grouping and sorting and why that's so important for an analyst. That'll lead us into an elementary understanding of EDA, or exploratory data analysis, and Tableau's support for EDA. You'll have an ungraded challenge, 070-030, wherein you are expected to gain an understanding of Tableau's support for elementary EDA, exploratory data analysis. We'll touch on the basics of candidate business hypotheses, formation, what are they, etc. And that will lead into course challenge 2 identifiers, 070-040, also known as challenge 200-020, rudimentary EDA, exploratory data analysis, and business hypothesis formation using Tableau within the context of the fictional course case project. Of course, there will be the midterm exam that opens on Thursday after this module is released at noon and closes the following Friday. So you have one day, 24 hours, to complete the exam, and there'll be some remarks about it just to refresh your memory. And then there will be a reading assignment to prepare for Module 080. So that's a plan for today. Business Analysis Lifecycle Part 2. Please be mindful, this is a approach to business analysis. It is not the approach. To my knowledge, there isn't a singular way of doing business analysis, but there are some well understood tropes, techniques, methods, approaches, etc. So this is one that has evolved over the course of about 4 decades and has proven to be very useful. And by the way, this term has many names. It could be called analysis, an investigation, an inquiry, an exploration, a project, an engagement, a life cycle, etc. The name is not what's important. What's important is the concepts and the natural evolution of how a business analysis effort unfolds. To get an understanding of this, let's first explore 5 highly iterative steps. And just be mindful, to understand iteration, you must first understand iteration. Haha, I do that for my own amusement. The first of the 5 highly iterative stages is activation. What are we intending to do? What's the purpose of this inquiry, this investigation? Why are we undertaking this? What are the drivers for this? Who expects what, when, how, etc.? Then we want to understand the problem that we're approaching. Recall a prior discussion where a symptom is not the problem, and trying to solve symptoms could lead to very bad results. So we want to understand what is the problem. That's sometimes called problem clarification. Then we want to understand the data. What kind of data do we have in order to undertake this investigation? What kind of analysis can we or should we undertake or not undertake? What analysis models might be inappropriate for the data or the problem that we're trying to undertake? And that's the analysis is, of course, dependent upon the problem and the solution and how well we understand those. And then stage 5, we communicate. So let's get into these. Activation. Activation is all about why are we undertaking that? What are we undertaking? When? Who? Possibly how? Sometimes that's left to discretion of the analyst, and that just is not expressed. But in the activation stage, we need to understand at least those first 4 questions, if not all 5 of them, and some others. But the one that's the most important is the why. What I found is, as an analyst, if you do not understand why you're undertaking the investigation, then it's very, very darn hard to produce a result to satisfy that. So that's step 1. Step 2, understand the problem. And to do that, we need to understand our context, which are externally focused factors such as marketplaces and consumer demand and customer preferences and technology changes and forces of opposition such as the competition, etc. The business analysis frame is a great way to start to gain an understanding of the problem. Second is situational, which is internally focused. What are our capabilities? What are our capacities? What are our business processes, etc.? Do we understand the problem as stated or the problem as observed? But neither of those is as important as understanding the problem. So, for example, in the course of my career, I've had executives say things to me such as, sales are down, we need a new marketing campaign. We'll call that the problem as stated or the problem as observed. And we're presuming that an executive had well-intentioned when they made a claim like that. They jumped from sales are down to we need a new marketing campaign. That seems to be a very logical thing to do. But is a marketing campaign the only reason sales could be down? What if its quality of the product has slipped, or pricing is too high, or the competition's gotten more aggressive, or customer demands have changed, or technology has changed? Aren't there many reasons why sales could be down? And some of those are not addressed or cannot be solved by a marketing campaign or an advertising campaign. So, do you want to focus on the problem as stated, the problem as observed, or the problem? Let's make sure we understand the problem. What caused the sales to decline is far more important than hastily preparing a marketing campaign that doesn't solve the problem. Be mindful to be wary of symptoms. Symptoms are, for example, sales is down. That's a symptom. It does nothing to explain the cause. So if you treat symptoms, you have done nothing to address or remediate the underlying cause. Step 3, data. So for any investigation, unless you're strictly politically motivated or something like that, or you're just going to work on aspirations, but if you want to apply rigor, intellectual rigor to undertaking analyses, we need data. Well, what data are needed? Well, that's defined by the activation. Why are we undertaking this inquiry? What's it about, etc.? What data are available? What needed data is unavailable. So we need data set X, it doesn't exist, or we can't acquire because it's owned by a competitor, or it's published by a data broker, but it's extremely expensive. It's $1 million data set and we only have a $500,000 problem or something like that. So if we do have a gap between what we need and what's available, how is that gap going to be handled? And that goes all the way from data sets down to individual values in a data set. What if we needed pricing data for products and some prices were missing? What do we do? Do we try to fill them in? Do we skip them? Do we delete the whole record? Well, you saw examples of this in the data wrangling exercise. They were highly simplified. There were the 2 scratched out lines in the handwritten journal. But that's to suggest that not all data is going to be present, not all data is useful. How are you going to fill in the blanks? How will the needed data be acquired and how will it be accessed? By access is meant more of a technical bit. For example, in Tableau, we use a connector to connect Tableau to a data set, which you should be familiar with. That leads us into analysis. Analysis of problems, not symptoms, problems. And a demarcation that's very important is, do we have a plausible understanding of causality? Doesn't mean guaranteed, but it should be more than just an opinion. And causality, by the way, that's causal, not casual. Causal means what caused the problem. Here's a blinding flash of insight. If you don't understand causality, how can solutions be developed? If you don't know what caused the problem you're addressing, how do you know that you can create a solution to solve it? Another aspect is to use analytical models to understand the problem and its causes. And analytical activities could include such things as mathematical or statistical models, very frequently used. Reasoning and other methods like that. You might be familiar with something called Mills methods or Popper's falsification. As an example, there are ways that reasoning can help us trying to analyze a data set or understand problems and their causes. And not all problems can be solved. We may find in very short order, it's happened to me many times, that a problem either can't be solved or can't be solved economically. When's the best time to find out you're wrong? As early as possible. Continuing on with analysis, then we want to analyze solutions. We want to establish a solution selection process first. Notice the sequence. We identify the selection process first, then we identify the solution alternatives. The reason I do this is because once people start articulating possible solutions, politics takes over. They become the owner or the proponent or the opponent to a specific technique or a specific alternative or a specific solution, and they want to argue for it or against it, frequently based upon some sense of ownership. As self-defense and to retain as much objectivity as possible, I found it helpful to get all the affected parties to agree in advance of identifying alternatives. How are we going to select the alternative for this solution? Are we going to pick the most expensive, the least expensive, the quickest, the longest, the ones with the least impact, the ones with the most impact? As you'll quickly find, there are many variables to selecting alternatives in solving business problems. Cost, time, and risk being three frequent ones, but that's not it. That's not the only set of factors. There may be a training implication. There may be a deployment implication. There may be some relationship implications. There are many factors that go into every business analysis choice. Then we want to establish the characteristics of the solution alternatives. For example, what's the nature of the alternative, the cost, the schedule, the risks, as I just mentioned. That leads us to some analytical models for solutions. We want to understand the solutions and the linkage between a solution or solutions, effects, and the causes of the problem. And if we can't identify a linkage, then what is the likelihood the solution will fix the problem? And that leads us to, again, analytic activities such as reasoning. And then we select the solutions to be implemented. Sometimes it's straightforward. Solution number 7 is the best. We should just do that. And sometimes it's less straightforward. Solution 3 is satisfactory, but it still leaves some aspects of the problem unattended. But if we undertook those other aspects, we would triple the cost of the project. So maybe we'll have a satisfying solution and not the best solution, or something like that. And that leads us to stage 5, which is to communicate our findings, our analysis, our results, and our recommendations. Most of the time, but not always, we are communicating with executives. However, regardless, we always must be mindful. Who is the audience? What does the audience expect? That could be somebody's reading a report or listening to a verbal presentation. What do they expect from the analysis effort? What are their mental models, their beliefs, their desires, their preconceived notion? The prototype report helps to address some of these questions. Then we prepare the communique, written and/or verbal. being mindful of its structure, its content, and what's called the mechanicals or the delivery. Mechanicals more applicable to a written report, such as margins, typography, spacing, things like that. Delivery, more applicable to a verbal presentation. And that's the 5 highly iterative steps. We don't do them in serial. We just don't go from 1 to 2 to 3 to 4. We do 1 to 2 to 3, back to 1 to 2 to 3, back to 2 to 3 to 4, back to 2, 3, back to 1, etc. So it's highly iterative. A specific skill common to most business analysts, at least all the ones I've encountered in the course of my career, is to understand and be able to accomplish grouping and sorting with a variety of technologies. For example, Microsoft Excel does this pretty straightforward. It's rather elementary. Tableau does this. It's elementary. You might be familiar with databases and the SQL language, structured query language, also quite elementary in SQL, etc. But understanding this is a very important skill for an analyst. So let's have a couple of examples. Let's say we have a rather small data set, as shown here on the left. There are 13 transactions spanning about 4 days. And we have a handful of customers and their zip codes and a handful of products and the quantities sold or that the customers purchased. Well, even with this small data set, with only 13 observations or 13 transactions, pretty hard to make sense of that, just looking at even this relatively small number of entries. So we might have some key questions. How many customers are there or were there during this period of time? How many customers are within which zip codes? How many customers purchased each product? That would be a count of customers. How many products have been sold? That's a quantity. Which products sell best by units? Worst? What's the average count of units per customer? Per product ID. Which products sell best in which zip codes? Which sell worst in which zip codes? And that's just to name a few of the many, many kinds of questions we might ask and on something as simple as one small data set. I'm going to transition here to each of the small number of examples, which has the same data set, but let's see if you can identify the differences. So here we are looking at the same data set and something changed. Can you spot what changed? Well, this data set has been sorted by zip code. Now, we could have sorted by zip code, customer, transaction date, etc., maybe product ID, but this is just to give an example. So now in one respect, we've sorted this data, but we've also grouped it. We can answer a couple of questions. By sorting it by zip code, we can say, what is the count of the number of customers within a zip code? So in 94088, there's 1. In 94102, we have 3. In 94920, we have 4. And in 95014, we have 5 customers. We can count those. Now, they're readily and easily countable. They're also groups, if you will. Let's look at yet another example. So here's example 3. What's different about this example? This version of the data set is sorted by product ID. So now we could answer such questions as, how many of each product did we sell? So product E8745, we sold 10. K5543, we sold 13. P3344 seems to be a good seller, etc. From this, you can conclude one of the most frequently used skills as a business analyst, regardless of what technology you're using, Tableau, Excel, Microsoft Power BI, SQL, etc., is the ability of grouping and sorting and knowing how to perform those two tasks. With an understanding of grouping and sorting, that leads us into gaining an elementary understanding of EDA and Tableau's support for EDA. I do want to stress this is rather elementary. It's about 1 inch deep and 1 mile wide. So let's talk first about the basics of EDA, exploratory data analysis. We first want to understand the provenance of the data. Now, if you're not familiar with that word, you might pause the video and look it up. But basically it means, where did the data come from? Where has it been? How did we become in possession of it, etc. Going all the way back from its origin, point of origin, to when we're now using it. What is the volume of the data we're dealing with? The variety of data, the velocity, the veracity, etc. In today's world, variety can include such things as audio data, sensor data, video data, etc. We also want to understand the degree of completeness. Are there any missing values? And if there are, what do we do about them? Are there categories or types, attributes, data types, ranges? A range means low to high. Do we have groups and clusters? As you saw in the prior very small example with the table of data, there were groups there. We want to understand the structure and the shape and the relationship between data elements. To a degree, you were doing that in the data wrangling exercise. And is there orders, natural order to a data set, sometimes called sort order? An illustration of that might be transaction identifier, or date, or customer ID, or product ID, etc. And the count of observations. Frequently, for example, in a relational data model, that would be the number of rows in a table. We also want to understand something called box and whisker plots, or something to the equivalent. I'm going to get more into that on the next couple of slides. And some other basic characteristics of some of the data. Where applicable, not all attributes in a data set are applicable to all of these measures. For example, many times textual data doesn't make sense to try to understand the min, and yet sometimes even textual data has a min. So we understand the min or the minimum value, the max or the maximum value, the average, the quartiles, possibly standard deviation. The only reason I'm putting that in brackets is many students in CIS64F have not had even an elementary statistics class and may be unfamiliar with the concept of standard deviation, along with correlations and regressions. So those are some of the things that we do in the EDA stage. So what is this EDA? Well, it's exploratory data analysis. It's credited to Professor John W. Tukey, who wrote this in remarkably thorough textbook here called Exploratory Data Analysis. And the emphasis is on the word exploratory. The intent is to gain a very early understanding of the data set. We are not testing hypotheses. If anything, after EDA, we might do some initial data analysis, but at this point, we're just trying to gain an understanding of the story and identify candidate business hypotheses, or in our case, as business analyst. If you were doing science, it would be just a candidate hypothesis. Typically, but not always, EDA is done visually. That's one of the reasons we're using Tableau in this course. It's useful, as mentioned, to gain insights into the story, and one of the most valuable things is to identify areas for further exploration, as well as to exclude areas that don't seem to be promising for further exploration. And we call that candidate hypothesis formation. By candidate, it implies, the use of the word candidate implies, it's tentative. This might be something that's worth following up on and exploring further. It might not be, but it's something that caught our eye. It's a candidate. We want to do some further examination and investigation of it and maybe test some hypotheses. So the objectives of EDA are to suggest hypotheses about the causes of observed phenomena, assess assumptions on which analyses, including statistical inference, will be based. By that is meant, if you have a statistics background, which statistical techniques might be applicable to this analysis in this data set. Are we going to use chi-square? Are we going to use student t? Are we going to use the Mann-Whitney U-test? Are we going to do regressions and correlations and things like that? That's intended to support the selection of appropriate to the nature of the inquiry and the nature of the data, analytical, statistical, and visualization tools and techniques. Overall, to provide direction for further data collection through observations, surveys, experiments, etc. Let me emphasize something in point 1. It says to suggest hypotheses. Those would be the candidate hypotheses. Keep in mind, they're tentative. At the end of the EDA stage, you should probably have one or more candidate business hypotheses, which you'll want to evaluate further. Another key aspect frequently, but not always associated with EDA, is called a box and whisker plot, or sometimes called Tukey's 5-tuple. And you may have seen diagrams like this, like the one shown here. You can see probably why it has the name box and whisker plot. So it's important to understand the concept of quartiles and median. Those are two concepts you should be familiar with, regardless of whether you've had a statistics course or not, although these are certainly covered in statistics. In the 5-tuple, there's a maximum value, and in a moment, for the moment, I'm excluding outliers. I'll get to that in a moment. We have a maximum value, we have the minimum value. In between, we identify the lower quartile, the median, and the upper quartile, as shown here. So take a look at the diagram on the right, which is something I just found on the internet and is supposed to be an example of diastolic blood pressure. So you take a number of samples. So notice how grouping and sorting becomes important. We take a number of samples and we perform a box and whisker plot on them. We take the data set, we want to identify the minimum value and the maximum value. Just for the moment, again, I'm ignoring outliers. Then we want to identify each of 4 quartiles. Each quartile is 25% of the observation, grouped together and plotted to give a sense of their range. From the minimum data point to the top of the first quartile, which is also the bottom of the second quartile, is the first quartile. From the bottom of the second quartile, which is also the top of the first quartile, to the median is the second quartile. From the median to the top of the third quartile, which is also the bottom of the fourth quartile, is the third quartile. And from the bottom of the fourth quartile, which is also the top of the third, up to the maximum is the fourth quartile. If you're not clear on that concept of quartiles, please stop the video and do some research and make sure you understand that. That's in a well-defined data set. What about outliers? Well, outliers, as shown here, are individual data points, maybe a couple of data points, but mostly individual, with abnormally large deviations from normal, kind of as shown in that diagram there on the right. So we have a cluster of data points down in the lower left, and in the upper right, far, far away from the cluster, we have one observation. Who knows why it's out there? It could be erroneous. It could have been a faulty sensor. It could be valid and worth following up on. How do we define an outlier? Here is a rule of thumb. It is not definitive. It's convenient. And by the way, recall that the acronym for rule of thumb is ROT. A convenient but not definitive technique to identify an outlier is a point which is more than 1.5 times the third interquartile distance above the boundary between the third and fourth quartile, or the first interquartile distance below the boundary of the first and second quartile. You might pencil that out. It's a little bit hard to understand, but outliers are significantly outside the range of what we're talking about. Box and whisker plots can be vertical or horizontal. There's no difference other than a choice on the author to display it one way or the other. Just to be clear, here's a boundary between the first and second quartile and a boundary between the third and the fourth quartile. And gee, I wonder if Tableau produces box and whisker plots. Oh, what do you know? It does. So there you go. That leads to challenge 070-030, which is not graded, and it is designed for you to get an elementary understanding of EDA and Tableau's support for EDA. So when you have a free moment, please go to the Canvas site, open the challenge, download the PDF, and read all the instructions. By the way, it's very important that you successfully complete this challenge, 070-030, before going on to the next one, which is graded 070-040. Let's take a moment and talk about the basics of candidate business hypotheses. The basics of them. Well, the basics is it's a candidate. That means it's preliminary. You might later on discard it. At least it's a place to start subsequent inquiries. It's based upon, or they are based upon, learning a dataset story through EDA. And it is a logical extension of exploratory data analysis. Candidate business hypotheses can be informed by such things as trends and counter-trends. Notice, by the way, the importance of grouping and sorting, gaining an understanding of a trend or a counter-trend. Sometimes, but not always, outliers are extremely important, and other times they're not important at all. Both cases, though, require professional judgment to determine whether you want to include, exclude, ignore, what have you, outliers. Box and whisker analysis is a great place to start looking for things. Once you become familiar with looking at box and whisker plots, you can get a very quick idea of the distribution of the data. Are there clusters that merit investigation? Those tend to be in very narrowly defined quartiles. Or is the data pretty diffused, widely defined quartiles? And much more. That's a backdrop for our next challenge, dealing with gaining a rudimentary understanding of EDA, forming candidate business hypotheses, and Tableau's support for EDA, which is challenge 070-040, also known as 200-020, rudimentary EDA and business hypothesis formation using Tableau. So, you know the drill. Please go to the Canvas site, read the challenge, download the PDF document, and away you go. Now that is due by 23:59 on the Sunday following the date this module is published. As we come to a close in this module, please be mindful of the midterm exam. That would be item 070-050, and a few points about the midterm to be mindful of. First, unfortunately, there's been evidence in prior classes of rather rampant cheating. I regret that these actions have to be taken as much as you probably regret them, maybe even more so, because I don't like penalizing the students with integrity and ethics for those that don't have integrity and ethics. However, to inject a sense of fairness for everybody, these parameters are in effect. All midterm questions are drawn from the midterm review guide. You are allowed one and only one attempt at the midterm exam. That means once you begin, you have to complete it. The midterm exam opens for student access at noon on Thursday. That's Thursday, following this module's release, and closes the following day at noon on Friday. So you have approximately 24-hour period to complete the midterm exam during the open time frame. There are 20 questions. Each question is a maximum value of 5 points for a total maximum for the midterm of 100 points. By the way, be mindful, as explained in the syllabus, of the weighting approach used to balance out differences between exams, quizzes, homework, challenges, etc. The midterm exam is timed. You have approximately 135 seconds per question, and you must complete the midterm within 45 minutes of beginning it. And there is no backtracking. Once a question has been answered, it is locked. Let me reaffirm For those students that are diligent and have ethics and integrity, I am so sorry that these parameters have to be enforced, but it's done so to ensure the integrity of the exam so that everyone receives a fair score. To prepare for Module 080, please complete these reading assignments before next week. Again, all of them are drawn from publicly available sources to keep your cost of education at a minimum. The Wikipedia article on descriptive statistics, mean, standard deviation, statistical inference. In the statistical inference article, please emphasize your understanding of the degree of models and assumptions. Very important. Please become familiar with the student t-test, chi-square test, linear regression, and Bayesian inference, not to make you an expert in Bayesian inference, but the important part is to understand the role of prior information. By the way, if you do go on to become a senior business analyst with maybe perhaps aspirations of becoming a data scientist at the graduate or PhD level, Bayesian analysis is a very important thing to learn. So at least here you're getting an introduction to the topic, but later on in graduate level courses, you probably would glean a greater understanding of it. In our next thrilling episode of CIS64F Module 080, we will discuss some elementary descriptive statistics, an overview of elementary inferential statistics, and an overview of elementary linear analysis, a way of doing trend lines, linear trend lines. Let me be clear about the challenge 200-020, the EDA with Tableau. When you read the PDF, you will find an example of a chart generated in Tableau that uses a non-linear trend line. I'm going to leave it up to you to figure out which type of trend line that graphic includes. But it's important to understand it's not a linear trend line. We are, however, in our discussion of these elementary statistical concepts in the next module, we are only going to explore elementary linear analysis, elementary linear trend lines. And that concludes this week's Module 070. Please be mindful to join online office hours. And with that, we are adjourned.